Hi, my name is Yashinie and my metric number is AA200859. I will explain about the introduction of our project. Our guru carried out an experiment aims to investigate the motion of a toy car on a ramp, which to study the relationship between the distance travelled by a car and the height of the ramp. This project is about the regression analysis. Regression analysis is a set of statistical method used for the estimation of relationship between a dependent variable and one or more independent variables. It can be utilized to assess the strength of the relationship between the variables and for modeling the future relationship between them. Regression analysis is also describe the nature of the relationship between the variables, that is positive, negative, linear or nonlinear. Regression analysis is based on 6 fundamental assumptions. The dependent and independent variables show a linear relationship between the slope and the intercept. The independent variable is not random. The value of the residual error is 0. The value of the residual error is constant across all observations. The value of the residual error is not correlated across all observations, and the residual error is values follow the normal distribution. A scatter diagram is a tool for analyzing relationships between two variables for determining how closely the two variables are related. Correlation coefficients are used to measure how strong the relationship between the two variables. There are several types of correlation coefficient, but the most popular is Pearson's. Simple linear regression is a model that assesses the relationship between a dependent variable and independent variable. The simple linear model is expressed using the following equation, that is y equals to beta naught plus beta s plus e error. The method of the least square is used to estimate the parameters. By using the least square method, we may estimate the unknown parameter beta naught and beta s in order to obtain the best 15 line for a set of data. The least square method can minimize the sum of square of the difference between the observed data and the regression right. That's all from me. The next person will continue their part.
Hi and Assalamualaikum. My name is Nur and Huda binti Muhammad Nawar, matrix number AA200986. I will be presenting the Fila table for our group, which stands for Facts, Ideas, Learning Issues and Action Plan. So number 1 for facts, each group is free to decide the ramp height and length. Number 2, increment of ramp height is consistent with the number of data. Number 3, experiment is repeated until the ramp reaches maximum height. Number 4, video of experiment and data recorded are included. For ideas, number 1, we use independent values for the ramp height in cms, which starts from 10, 15, 20 on to 45, 50 and 55. For number 2, tabulation of data is constructed before conducting the experiment. And number 3, recording of experiments conducted are short and precise. On to learning issues. Number 1, how will group members solve the question despite being far away from each other? Number 2, will the data or solution be uniform and neat when compiled? And number 3, question of accuracy of data. As for the action plan, number 1, we held group discussions using WhatsApp applications. Number 2, compilation of data is done by sharing Google Drive links. Number 3, the experiment, tabulation of data and solving questions are done gradually with a considerable amount of time provided in between. And lastly, number 4, we refer to the lecturer's lecture and notes. That's all from me. Thank you.
Assalamualaikum and hi, my name is Alia binti Aududin with metric number AA20298. So I will continue with the problem background of the experiment. So in this experiment, there is two variables, which is independent variables x and dependent variables y. So in the experiment, the dependent variable y is the distance traveled by the toy car beyond the ramp, and the independent variable x is the height of the ramp in centimeter. The purpose of this experiment is to investigate the motion of the toy car. So I will now continue with the steps to conduct the experiment. So the first one, I will need a table for the ramp. The second one, I will use a lot of books for the height. And the third one, a toy car and a measuring tape. So I will set the place And I will put the table at the height of 10 centimeter. I have taken the measurement of the value set on the cardboard to determine the height of the RAM is accurate. Okay, now I will put the table at the 10 centimeter height of the RAM because we will start the experiment with 10 centimeter and end with 55 centimeter, which the difference between the height is 5 centimeter. So since the independent variables can be manipulated, we will start with 10, and I will put the card at the end of the RAM, and it will go down the RAM until it stops. And then I will measure the distance traveled by the toy car with the measuring tape, and I will record the measurement in a piece of paper. So the second step is I will continue the experiment twice before I add on the height with 5 centimeter, because we will need the data for investigate to determine the correlation between the height of the RAM and the distance traveled by the toy car by observing the scatter diagram and calculating the correlations coefficients. So we can also observe the trend of the data and make prediction with the least square regression line. So the third step is we will build the table and complete it. So here is our data. Before I continue our presentation about problem and solution, I would like to introduce myself. My name is Sofia binti Muhammad Nizam. My matrix number AA201076. So I would like to explain solution for question 1 and question 2. In question 1, I have to draw a scatter diagram using Excel. In scatter diagram, I have to draw about mean measured distance traveled by toy car versus height of RAM. Now, as we know, mean is the average of data that we collected for several times. In this experiment, we repeat the experiment with the same height of RAM for 3 times. So in order for we to find the average of data, we have to sum all of the 3 data that we collected and divide by 3, because formula to find mean is to sum all of data that we collected and divide by how much we repeat the experiment. So as you can see in the slide below, that is the result of scatter diagram that I've drawn using Excel. Solution for question 2, I have to interpret the diagram that I've drawn using Excel, which is the scatter diagram from question 1. And I have to answer if scatter diagram exhibit a linear relationship for two variables. As you can see in the slide, I added a linear line in scatter diagram because in order for me to answer the question, does scatter diagram exhibit a linear relationship for two variables, I have to edit the linear line because as you can see, the points in scatter diagram are closer to the linear line. So
That means if the height of ramp is increased, so the mean is measured distance traveled by toy car will increase too. So the two variables have a linear relationship. This also shows that the data that we collected is a positive correlation because the line is keep increase in the scatter diagram. So that's all from me. I will pass to Ling to explain our solution for question 3 to 5. Thank you.
Hello, my name is Ling. My matrix number is 88200758. Now I will continue the presentation with the solutions for question 3, 4, and 5. Question 3 asks us to calculate the linear correlation coefficient for the data and interpret the given answer. Before we calculate the correlation coefficient with the formula, we have to build a table and calculate all the components like x squared, y squared, xy, and also all the dimensions of x, y, xy, x squared, and y squared. As you can see at the bottom of the table, they are all the dimensions of each column. The purpose of drawing the table is to minimize our carelessness when calculating all the data needed. Then we just have to insert all the values into the formula. First, we insert all the dimensions and the number of data into the respective formula as xx, as yy, and as xy. Then we just insert the calculated values into the correlation coefficient formula, which is r equals to sxy dy with the square root of sxx times xyy. The answer we get for correlation coefficient is 0.6295. Therefore, r equals to 0.6295 indicates that there is a moderate positive relationship between the height of the ramp and the distance traveled by the toy car. Let's proceed to question 4. Find the least squares regression line. To solve this question, the sxy and sxx from the previous question is needed. Sxy divide with sxx to get the value of beta hat 1. Beta hat 1 for this data is 2.6674. Then, to find the value of beta hat naught, the formula is y bar minus beta hat 1 times x bar. Then, the value of beta hat naught we get is 54.3095. Lastly, substitute the values of beta hat naught and beta hat 1 into the regression line equation, which is y hat equals to beta hat naught plus beta hat 1x. So, the regression line equation for this data is y hat equals to 54.3095 plus 2.6674x. This is a sketching for the regression line equation. The last question, question 5, is to predict the value of mean measured distance traveled by toy car when the height of ramp is 200 cm. To solve this question, substitute the 200 cm into the x in the regression line equation. Then we will get the predicted value of the mean measured distance traveled by the toy car, which is 587.79 cm. That's all from me. My groupmate will continue with the following part. Thank you.
Assalamualaikum and hi. My name is Arina binti Yahya, and in this video I will share to you the conclusion, which I will conclude each of the questions for this task. So for question 1, the scatter diagram helps to describe the relationship between the two variables, which is the height of the ramp and the distance traveled by the toy car. By using the mean from the experiment results, there is a linear relationship between the height of the ramp and the distance traveled by the toy car. Next, for question 2, the points are close to the line with a positive gradient, so the linear line displays a positive correlation. Next, for question 3, the correlation coefficient indicates that the height of the ramp and the distance traveled by the toy car have a moderately positive relationship. This shows that the toy car performs admirably. Next is for question 4. By using the least square method, we may find the unknown parameters to obtain the best fitting line of the data. So the regression line shows a linear relationship between the height of the ramp and the distance traveled by the toy car. And last but not least, for question 5, the mean anticipated to be 587.79 cm when the height of the ramp is 200 cm. So we fill in the value of 200 in the least square regression line equation. So that's all from me. Thank you.